Hey, welcome. Today, we are diving headfirst into one of the biggest revolutions happening in tech right now, how artificial intelligence is being built, trained, and scaled up in the cloud. And look, this isn't just some small upgrade. We're talking about a completely new way of building the future, piece by piece. Seriously, just think about it for a second. That photo app on your phone that somehow magically tags all your friends, or your streaming service that just knows exactly what movie you're in the mood for. Well, the secret ingredient behind that incredible leap in intelligence, it isn't just AI. It's the powerful, game-changing combination of AI and the cloud. So to really get a handle on this revolution, we got to look at the massive shift that's taken place. It's a total move away from the old, clunky, rigid way of doing things to this new, super flexible, cloud-native approach. And this slide just says it all, doesn't it? Over on the left, you've got the old world, on-premise. Just picture a physical server rack, maybe humming away in a closet somewhere. It's limited, it's expensive, it's rigid. But then you look to the right, and that's the new world, cloud native. It's not one box, it's this elastic, fast, on-demand network of resources. It's a totally different universe. Okay, let's really break this down. The old way meant you had to spend a fortune up front. That's what we call capital expenditure. You were literally limited by the physical space in your server rack, and trying to scale up was a slow, painful headache. The new cloud-native way? It just flips that entire script. You pay as you go, kind of like a utility bill, and you get access to what feels like infinite computing power. This means you can get your AI applications out there and scale them with unbelievable speed and agility. So what's really pushing this massive shift? Well, it pretty much boils down to three core advantages, or as I like to call them, the three cloud superpowers. And here they are: scalability, accessibility, and cost efficiency. You put these three together, and you start to see why building AI in the cloud isn't just another option, it is a complete and total game changer. Let's dig into each one. First up, scalability. You see, AI models, especially the deep learning ones, are just incredibly hungry for power. Back in the day, this meant you had to go out and buy rows and rows of expensive, specialized hardware like GPUs, those graphics cards that just happen to be perfect for AI math. But with the cloud, you can tap into that massive power instantly, right when you need it for training, and then just scale right back down when you're done. No more crazy expensive hardware just sitting there collecting dust. And all that power is now more accessible than it has ever been. This is huge. I mean, the cloud literally democratizes AI. You no longer need a PhD in computer science to build something incredible. Cloud providers give you these pre-trained models through simple APIs that can handle really complex stuff like image recognition or language translation. You basically get to stand on the shoulders of giants, using their groundbreaking work as your starting point. And all of this, naturally, ties into our final superpower: cost efficiency. By ditching those massive upfront hardware costs and switching to a flexible pay-as-you-go model, powerful AI development suddenly becomes possible not just for the tech giants, but for startups, for researchers, for developers, for everyone. All right, so now that we know why we're all in on the cloud, let's talk about what we're actually using. The best way to think about it is like an AI builder's toolkit with different layers of services you can choose from depending on how hands-on you want to be. And this is what we call the ladder of abstraction. Just think of it in three simple levels. Down at the very bottom, you have infrastructure as a service, or AaaS. This is the raw foundation: the servers, the storage, the networking. Move one step up, and you get platform as a service, or PaaS. This is like your fully equipped workshop. It's got managed environments that really streamline the whole AI workflow. And then at the very top, you have software as a service, SaaS. These are the finished, ready-to-use tools, like those amazing AI-powered APIs we were just talking about. Okay, so we've got our tools. Now, let's walk through the actual blueprint for taking a bunch of raw data and turning it into a real working AI application. This is the incredible journey from data to intelligence. Now, at a high level, it's really a four-step journey. First, you ingest the data. That's just getting it from all your different sources. Second, you process it, cleaning it up and getting it ready for training. Third, you train your model, using clever algorithms to find patterns in that data. And finally, you deploy the model, which means making it available for people to use out there in the real world. Now, this slide shows how those steps actually get built out in a modern system. You've got things like a central data lake for all your raw data, and a model registry to keep track of your trained models. But I want to point out one absolutely crucial component here: the feature store. This thing is key because it prevents a nasty problem called train-serve skew, which is basically when the data you use to train your model doesn't match the live data it sees in the real world, causing it to make bad predictions. A feature store makes sure everything stays consistent, which makes your AI a whole lot more reliable. So we've covered the why, the what, and the how. Now for the fun part. Let's see how all these pieces actually come together in the real world with a really powerful example of this architecture in action. Let's talk about a smart energy grid. You've got all these sensors on power lines, and they're constantly collecting data. That data gets streamed to the cloud, where AI models are analyzing it in real time. The insights from that analysis are then used to power some incredibly smart applications. So what can these applications actually do? Well, for one, they can do predictive maintenance, analyzing sensor data to predict when a piece of equipment is going to fail before it happens, which helps prevent blackouts. They can also do load forecasting, using historical data to perfectly optimize how power is generated and distributed, making the whole grid more efficient. And with something called Edge AI, you can even put lightweight models directly on the grid devices themselves for instant real-time responses. Pretty cool, right? But it's not all smooth sailing in this new frontier. With all this incredible power and complexity, there are some really important challenges that you've got to manage carefully. Two of the biggest hurdles are cost management and data sovereignty. I mean, that on-demand power is amazing, but it can lead to what we call cloud bill shock if you accidentally leave expensive resources running when you're not using them. And then there's data sovereignty, which is all about making sure your data storage and handling complies with local laws, especially when it starts crossing international borders. You've got to have a plan for both of these. And that really brings us to our final thought for today. We've seen how cloud AI can make our critical infrastructure, like the power grid, so much smarter. But as this technology gets woven deeper and deeper into the fabric of our society, the really crucial question we all have to face is this: how do we make sure these systems aren't just powerful and efficient, but that they are fundamentally secure and robust? Answering that, well, that's not just a technical problem, it's the next great challenge on our journey into this AI-powered future.